Hello and welcome everyone to this month's jam session. Why can't we be friends? AI agent collaboration in the world of data engineering. So let's begin. I think by now all of us realize AI agents are everywhere. And more will be here tomorrow. Why is that? Well, it's basically the business benefits, the customer service improvements, IT resource and performance optimization, new product development, acceleration, supply chain, et cetera, et cetera. These new workflows with agents are really changing, revolutionizing how business is done. But in a world of agents, where does that leave people? Will we become the horse at the advent of the horseless carriage? Are we going to become the bookkeeper in the advent of financial software? Steve Jobs once said, great things in business are never done by one person. They're done by a team of people. Well, in today's AI agent environment, I think Steve might amend that to say, great things in business are never done by one person. They're done by a team of people and agents. So let's test that statement today in the data engineering domain. And we'll talk about the AI agent collaboration opportunity. To do that, to explore this topic in more detail, we've brought together an Inside Jam session with experts, including William McKnight of McKnight Consulting Group, Kibos Barzan Bozpari, DataOps.live, Guy Adams, and TensorStax, Arya Attar. Welcome, everyone. Let's have you guys introduce yourselves to the audience. Start with a little bit about yourself, your organization, your role there. And we'll start with William. Hey, William, longtime friend. How you doing?
Hey, Bob. Hello, everyone. William McKnight with McKnight Consulting Group. I've been in the data space a long time, and I run a consultancy, and I'm an industry analyst.
Great, William. Thank you so much for joining us today. Barzan, Kibo, you've been on my show several times. I love you as a guest because of the insights you bring. Tell us about yourself, Kibo.
I'm a professor at the University of Michigan, Ann Arbor, but I'm also the founder and CEO of Kibo, a company that uses data learning. I'll tell you more about Kibo later in the show, but I've spent the last 2 decades of my career essentially teaching, building, and selling database systems and AI. Essentially, that's being the quick summary of my career. I get excited whenever people talk about machine learning and AI and data. That's my passion.
Great. DataOps.live Guy Adams. Yeah, that's the second time on the show, right, Guy?
Yes, it is, Bob. Yeah. So I'm CTO. Thank you. I'm CTO and co-founder of DataOps.live. I've been doing that for 5 years. My background is in the software development world. 20 years building and scaling software engineering organizations. So, but yeah, now 5 years, I guess, qualifies me as somewhat of an expert in the data space, particularly DataOps. We really focus on helping our customers at enterprise scale build, test, manage, deploy data products at scale. And historically, that's been focused more on the data engineering personas. But what we've seen is a great convergence of the customer's desire to democratize that and push that out to the business and the business domains has come just at the right point for converging with AI and the ability for that to make what were previously very, very complicated things requiring specialist skills and expertise all of a sudden available to a much wider range of people.
Great. Thank you. And welcome back. Arya, first time. Tell us about yourself and your company.
Yeah, nice to meet you all. My name is Arya Attar, co-founder and CEO of TensorStax. I've been working on deep learning models since 2018. So in the kind of early days of computer vision is when I started getting involved in the space. We started TensorStax about 1.5 years ago, recently closed out a $5 million seed round. And we're building autonomous AI systems to help build and maintain the infrastructure at scale across tools like Spark, dbt, Airflow, and directly integrating with data lakes and data warehouses that are very commonly used across the industry today.
Well, welcome. Good to know about another company that's really focused in this domain because there's so much going on. Let's begin. Why don't we just take it really high on the collaboration subject in general? What is the state of agent and human collaboration today? Where are we? Are we early innings in a long learning cycle here, or have we made a lot of progress? Where are we? What do you see out there? You're an industry analyst, so you look at this all the time.
I do. I see a big rise of AI agents. Vendors are all over it. Companies out there are all considering what AI agents to use. Most of this is in kind of proof of concept development phase at this point, but I do believe that will change by the end of the year. And AI agents are going to be a huge trend that we're going to be dealing with. I've often wondered over the past few years, how is AI going to get into the enterprise? Well, I think we have our answer. It's AI agents, and they're being designed way more discreetly these days so that they do discrete tasks. And then there are organizational elements that that surround the agents and put them together in a meaningful way to do a bigger task for the enterprise. And so now we see enterprises able to manage supply chains, check out targeted marketing, do predictive analytics, and so on, all with the use of agents.
So the agents themselves are doing distinct tasks in a workflow
Yeah,
that might have human collaboration in it.
right.
Okay. How about you, Guy? What do you see in the kind of agent domain? And so you mentioned that you're seeing it kind of opening the doors to some more less technical people being involved in more higher or more difficult data engineering tasks.
Yes, I think, we've got an interesting position because we see two sides of it. On one side, we've got customers who want to use the agents that we're building, but of course, we're also a software engineering organization with a bunch of engineers who are actually using the technology day to day. And I think the collaboration, certainly in the last 6 months, I've seen almost turn on its head. Like the analogy that the Steve Jobs quote used at the beginning about teams is a really relevant one, because if I go back even 6 months ago, I look at our internal engineering, we had a team of people, and each of those people were made more efficient by the use of AI and AI agents. They would delegate individual tasks. Write me a function to do this, add me a unit test for that, debug this for me. And almost what we're seeing is that turning its head. And now the engineers that used to be specialists, they were a SQL engineer or a Python engineer or a cloud infrastructure engineer, they've almost all been elevated to team leads. Every team member, as of 6 months ago, is now a team lead. And each of them has at their disposal a team with a SQL expert or AI agent, and a JavaScript expert, and a YAML expert, and a dbt expert, and a Snowflake expert, and so on and so on. And at a high level, their role hasn't changed. I always define an engineer as a problem solver. Technology, good engineers, like good software engineers, they've been changing languages every few years just as things roll. Engineers are not cloud anyone technology. Engineers are fundamentally problem solvers. So they are still engineers, they're problem solvers, but what they're now doing is being that mediation between that team of agents. And it's, for me, it's less of a workflow kind of ABC and much more of a these things bouncing off each other, but with that team lead being the voice of reason in the room, the cat herder, if you will, to try and actually make sure they end up at the end point that you want.
And the team meetings are short.
Very short. Less arguments as well.
No, that's actually a very interesting insight, where the human is kind of the central operating system between the agents and coordinating and trying to figure out what they should be doing, and then defining ways to have them work together. Interesting insight, Guy. Thank you. Aria, what are you seeing on the agent front in general and collaboration?
Yeah, I think it's on two layers, both internally on like how we use these systems with tools like Cursor, internally building TensorStax, and for our customers using TensorStax, interacting with like dbt, Spark, and Airflow. Is I think one of the major trends we've seen is these tools are really unlocking the ability for these engineers to iterate significantly quicker than they previously would be able to. That's pretty much what we're seeing internally as well. Is the iteration speed between each cycle of development is going up by orders of magnitude. And the difficult aspect of getting these agentic systems to like almost one-shot a problem is this idea that the requirement gathering step is a lot more difficult than I think a lot of people expected it to be. And that's partially why product managers and project managers kind of exist, right? Is for that requirement gathering stuff. And I think that's one of the missing components for getting these agentic systems to like kind of move to that next level of like almost one-shotting a lot of these tasks is because the requirements often are very clear. So the way they're being used most often today is in that collaborative sense, like you mentioned, because that requirement gathering stuff is so difficult, which is maybe not so bad because it allows the user to like iterate very quickly and eventually end up at the state that they're looking for. And that's, we're doubling down very heavily on this idea of collaborative iteration and just like making each iteration speed between each DBT model or Airflow DAG seconds rather than hours, which you previously were seeing.
That's really interesting. Get that first of all, the iteration speed concept, using agents to accelerate cycles and continuous improvement. But the second thing you said was this idea of changing the focus now on requirements gathering than the auto generation. Dan, did you mention that? I wasn't clear where you're talking about the requirements gathering being more important in general, but is there an iterative thing of using agents to help with the requirements gathering?
Pretty much, exactly. So the way that previously things were done, right, is you would have a PM go require a lot of gather a lot of requirements on, you know, what is the data model that we're looking for, what are the metrics that should be included in this data model, what are the sources that we're reading from, right? This would likely take days or weeks, and you would assign that to a team of engineers, and they would just go off and spend more time building it out, right? The way it's done now is the engineer just gives some high-level requirements of more or less what they think they're looking for, and they basically instantly get a preview of the data model, right, without having to spend multiple weeks. Now, as an engineer, once you see that data model, you get a lot more clarity on like whether or not it actually fits more or less what you're looking for or not, right? And the next step of rebuilding that data model to like push it a little closer to what you're exactly looking for, even if you don't have 100% clarity, is now significantly easier and faster because it's right in front of you, the V1 of it, right? So you're almost able to just take results directly rather than spending multiple weeks gathering these requirements and then iterating on that aspect, right? So there's aspects of these models that we can definitely talk more about later that are like very below human intelligence. The perspective we internally have is these models are not intelligent at all. They're very knowledgeable, dumb models, right? They make a lot of trivial mistakes like we've seen, but they're very knowledgeable. You can ask them about anything, right? But there's aspects of them that are absolutely superhuman today that I think if we lean into when building these agentic systems, it unlocks the capability of when you combine them with actual human intelligence, you get almost super data engineers to a certain degree, which is incredible to see in our customer base.
That sounds good. Super data engineers. All right. Bardzon, agents in general, you've been working in the machine learning domain a long time. What are you seeing in this area of agent collaboration and just progress on the agent front in general?
I would say, like, just from a pure technical perspective, when I look at the state of the art with LLMs and where we've gotten the machine learning and reinforcement learning and in general with Gen AI, the technology is clearly ahead of the adoption. In other words, there's a lot of room for improving the models we have, you know, in terms of like safety, security, privacy, bias, fairness, hallucination, all of that stuff. There's a ton of work for us to do as machine learning, researchers. But like on the business side of this, if I put my CEO hat on, I think the adoption has not caught up with where the technology is right now. And I think a huge barrier right now is the human element, right? There's a lot of fear, especially on the engineer side. I think someone on the panel pointed out that engineers are by training problem solvers, right? But they're going to remain as problem solvers. But I think what happens is that there's this fear of like how we're going to solve problems. There was this, I think it was 2003, if I'm not mistaken, there was this study about, engineers, I think it was on GitHub, like, using Copilot, and they saw a clear 20 to 55% increase in productivity for engineers who are leveraging Copilot, for writing code, unit tests and writing code snippets and code reviews for them. So I think that there's like, if I just look at it from a pure technology perspective, I think, we're going to see this gap narrow down, like go down a little bit, get smaller over the next year and a half, 2 years. I think 1 year might be a bit. I think we're going to see progress, but I think it's going to take about at least 2 years before the adoption catches up with where the technology is today. In other words, the AI can do more than what we're trusting it to do today. But then if I just like kind of zoom back and zoom out and sort of look at it from a higher level, like this, when we talk about agents, right? Like we're talking about the machine learning that we're trusting and we're taking an action, right? That's what an agent means. But if you think about it, like, that's not new. Like, that's exactly how ad placement has worked for the past, 25 years, right? But the problem, I think what's new here is that, okay, an ad placement was a very well-defined, specific, let's say, classification task, that there's a very narrow scope that we're trusting with a one-time decision of what is the ad that will maximize the likelihood of this viewer clicking. Whereas now we're talking about more dynamic, continuous learning environment where there's feedback from the user, from the environment. We're more in the realm of reinforcement learning, but also we're talking about open-ended problems, right? So if I were to sort of kind of jump the gun, I would say where we're going to see the biggest adoption is where we're basically dealing with problems that are safer to adopt AI. So when we started Kibo, about 3.5 years ago, when we actually brought the first fully automated Snowflake optimization. I mean, now, we support Databricks as well. But I think the choice we made there was that, okay, what is that one thing that gives the biggest ROI? And I think this is going to be key to increasing adoption of AI agents, is that what's that one area where the risk can be minimized, right, to the business continuity, and the ROI would be immediate and obvious and very tangible. And that's why we said, how about we use reinforcement learning and AI agents to actually automatically optimize the customer's infrastructure, in particular Snowflake and nowadays Databricks, so that they're not worried about, what happens to unfairness, what happens to the bias. Like, there is no bias. Like, I reduce the size of your warehouse and you save the $30 during those 20 minutes. And then over the month, like the course of the month, you save $100,000. So those risks are lower. And then if you sort of reason about, okay, can we train these models without having access to sensitive data, so that we just shut that door up front. I think data engineering, which I think is one of the topics you guys are gonna, we're gonna cover in this panel, is actually one of the smartest places to start with that adoption, right? So the thing I always tell people is a lot of engineers are afraid of losing their jobs to AI. And my response is always like, if you're afraid that AI is gonna take over your job, it probably is. So the solution is not to resist it, but to sort of embrace it and figure out how to use it more effectively.
Want more Insight Jam? Subscribe to our YouTube channel for shorts, panels, podcasts, and more. In your shorts feed, enjoy a daily dose of best practices from tech experts and leading solution providers, while long-form panel discussions and keynotes, recorded live every quarter, go deep on important industry topics. And don't miss our collection of regular podcasts, keeping you informed on the latest trends. We're hard at work collecting the best enterprise technology information from around the globe, so subscribe to be notified of our next upload. Now, let's get back to the show.
Well, great. You're talking about the best places to use agents at this point, or the areas with the highest returns, and very focused problems, and that in your belief that data engineering is a good place to start. So let's explore that one in more detail. Which data engineering tasks then are the best candidates for AI agents? But not only which are the best, why is that? What's the reasoning behind that? And let's start with you, Guy. What do you think? Which tasks are you seeing internally and in your customers, and why are those the right ones for AI agents?
So I think it's tricky because, and I hope this goes out with the date on it, because I think all our answers are going to date pretty radically. In 6 months' time, we'll be embarrassed by everything we've said because it's moving so quickly. But to me, the ones that we focus on most are the ones where generative AI just radically changes the economics. So I'll give you 2 examples. Engineers are expensive people, irrespective of geography. You look at the whole, engineers are expensive people. That means that I've always got this much I want to do and this much I can afford to do. And generative AI just completely changes the economics of that, to the point where we did a hackathon recently, and one of the projects was like, let's just see how unbounded these problems can be. But rather than telling my software I want this feature and that feature and that feature, they build me a feature that will delight my users. Done. No more direction than that. And you know what? There were some terrible ones and there were some okay ones, and there was one or two good ones. But the cost of each of those experiments is $1 or $2. So what's to stop me running that experiment 50 times overnight and coming back in the morning, I've got 50 new features and I can quickly reject, 48 of them, but 2 of those new features might actually be meaningful features to my customers. That's something, it would have cost me, a couple $100,000 to do that with people. So it's an area where the economics of AI have just radically changed things. I'll give you another example that working on very active for us at the moment is defining automated testing, data quality testing for data. I've got a terabyte of data and I want to go through and work out what is a sensible data quality test for this, that, and the other. That's an awful lot of data to analyze, even with sampling. There is no meaningful way that I can get a human being to analyze even a sample of that to suggest what sort of data quality testing I might do. But I can absolutely get an AI to do that. And I can get it to iterate, and I can get it to propose a first set of tests, and then I can get it to apply those tests to a different subset of the data and see if they stand up, and so on and so on. So, those are two very different examples, but both of them are based on the fact that I can do 3, 4, 5 times orders of magnitude more work for the same number of dollars, and that just completely changes the options that are open to us.
Got it. William, what do you see? You've been out in the database world and hacking data warehouses and building them and that sort of thing. A lot of manual stuff in your background. But as you think about data engineering workflows today, what you're seeing in your clients, where do you see these data engineering opportunities for agents?
So in pretty much everything a data engineer does, AI agents can offer a second opinion on that. Some of our creative, uses of agents are to generate the unit tests for the code that we deliver, to create the documentation for the code. Always a tedious task, and really hasn't been done much until we now have agents to do that work. And doing code reviews, getting that second opinion on what we're doing, maybe some good ideas. We've seen some good ideas come through already from AI agents. So while we might not originally use AI to generate code, to review the code, I think that's the least that we should be doing with AI agents. So it's not the high level architecture, the strategic decision making or complex problem solving, but it's all these things that an engineer does that require, even if he or she is a drop dead expert on what they do, if it takes them 30 seconds or less to think about it, I think that is something that an AI agent can take in the information and just do, and take that off the table of the data engineer. And those things that the data engineers do today that they might consider easy, okay, that's something that's a candidate for AI agents to take on. The things that are hard, maybe that's where the junior developers are coming in. So the floor, it's just getting raised hard and fast right now as a result of agents, but there are some uses for agents.
So,
Go
ahead,
Matt.
Matt.
I was just going to say, you're talking about code review. The very first use case that we implemented internally for AI was actually writing merge request descriptions. And it's universally true that every single merge request description I've seen come from an AI is better than the best one I've seen from an engineer. And it's not because the AI is better at doing it, it's because it has an infinite boredom threshold. The better the engineer, the less their tolerance to sit down and write a long, descriptive, meaningful merge request, because they've got other jobs to do. AIs don't get bored. So that was the first one where every single time the AI is doing it, it's doing a better job, not because it's more capable, but simply because it's not getting bored of this and wanted to jump onto the next thing.
Yes.
So from a human point of view and the collaboration point of view, unleash your best engineers to do their best engineering. Arya, what's your point of view here on data engineering opportunities with respect to AI?
Yeah, so like I said earlier, I think there's aspects of these models that are absolutely superhuman today, and it's important for us to understand what those are and actually lean into them, right? For example, you and I cannot read 20,000 database descriptions in parallel at once, right? That is just physically not possible for a human to do. But if you parallelize these models to a certain degree, they can do that right now, right? And that's something that's implemented within TensorStax, where, for example, we have a customer that has 22,000 tables in one Snowflake database. And that's something that in reviewing those schemas and actually figuring out what are the metrics that we're trying to access in the first place is just not something that a human can ever do, right? So there's aspects of this in terms of just like figuring out what are we working with, how are we going to actually build out this model, how are we going to build out this end-to-end pipeline that the models can do very well today. Now, the direction that this technology is headed, I think, is it's very important to note. Like Guy mentioned, the opinions change down the long term, but we're very clear with this. The end state of this technology is end-to-end autonomy, right? And that's okay, right? What differentiates humans from other animals is our ability to use tools, right? And when you kind of look at it, like any major technological revolution that we've had over the last 100 years, right? For example, the Industrial Revolution, if you kind of think about like farming as an example, what really pushes just society to the next degree is just like automating major aspects of things that are done manually now. And what the humans end up doing is, like I said, a lot of that requirement gathering and figuring out what are you farming, what are you building in the factory, right? And then operating that factory and ensuring that it actually works properly, right? I think a very similar idea will be applied to engineering at like a broad scale. Same thing with data engineering, where my personal opinion is data engineering is a lot more rigid than software engineering. There's a lot more things that can go wrong, right? If you're building out, a Spark pipeline, every single token that comes out of the language model has to be 100% correct. So there's a precision aspect of it that we have to get right, which is a lot more difficult than regular software engineering. But what I think will be done in the short term is just like a lot of the boring aspects of it, right? Writing tests for data models, creating new schemas, writing, descriptions for each new table that we add inside of the data warehouse, data lake, and so on. And really just like on the more important aspects of it, getting the data engineer to base 1 or 2, rather than having them start from base 0, right? Starting with a data model that's 80%, 85% complete and having them fully finish it off. That's being done today. And down the long term, it will be end-to-end autonomy of the whole pipeline, writing the tests, writing the schemas, writing the descriptions, docs, and so on. But I think that's still probably a year or 2 out. And when that does still come around, again, the important task that the humans will still be able to do and should continue doing is requirement gathering, figuring out what actually needs to be done and where's the end value to the customer, right? Because you could run these models in parallel all day and they'll generate things all day, but you don't know if any of it will actually be valuable, right? So you still need someone to actually figure out what are we doing and why are we doing it in the first place, which these models I don't think will be able to do well in the midterm, at least. So just the boring things and the things that take a long time to do, such as writing the test and at least just getting the data engineer 80% of the way there.
Got it. So boring in the long, again, big time consumers. Barzan, what's your thought here within data engineering? Where do you see tasks, or what are the characteristics of tasks that are best suited for automation and AI agents?
I think there are 2 things that need to go hand in hand. One is the mindset of the data engineers and the decision makers within the organization. Like that changes with education, actually. Provide the right education and thought leadership. Like the AI cannot change the mindset of someone who looks at AI as, oh, this is my enemy, this is what's going to take away my job, right? Like I think the technology progressed much faster than our education system. Like a lot of our engineers on the market often don't even have computer science like training. Like, they were a chemie or a physics major, and then they took a bunch of Python classes online and they got into software engineering and all of that. But even the computer science majors did not have as much AI and LLM training when they were back in school. And so one aspect of it is the human psychology portion of it and the mindset. And the second part is picking the right problems to start with, right? Like you wanna walk before you run, right? So for the first part, the way I look at this and the way I've sort of tried to kind of educate those around me who are basically dealing with these decisions and these sorts of dilemmas is that the way I like to think of agents or AI agents is think of them in the context of data engineering, think of them as an infinitely patient, infinitely competent data engineer. So the keyword here is collaboration, Bob, which you mentioned at the beginning of this thing. If you actually look at AI from a collaboration perspective, that, hey, now I have this colleague who doesn't get tired, who doesn't get bored, who doesn't complain. He'll do whatever I ask him to do. And he's not someone who needs, like, he's actually pretty good at what he does, right? So if you sort of look at it this way, then the next question is, okay, what are the problems we start with? I think there's 5 areas in my mind within data engineering which are absolutely ripe for adoption, right? One of them is no different than software engineering in general, which is code gen. I think your other guests have also alluded to this, right? Like, yeah, we start with maybe, unit tests or increasing unit tests to increase coverage. I think there were studies, if I'm not mistaken, 2024, there was this study where I think it was Facebook, actually, Meta did this thing where they realized by using LLMs, you could actually increase the code coverage for unit tests by 25%, right? So that's the same thing, right? You need unit tests, you need a lot of that essentially skeleton code writing and code gen on the data engineering side, just like you do with Java software engineering. So that's no different. There are things you can do there already. It's like, you're looking at a 20 to 55% increase in productivity. But there's 4 additional areas within data engineering, which I think are even better suited for where the technology is today when you think about adoption. So I would say the first one is obviously the data quality aspect of it, right? So data quality is one of the most, like, if you think about it, up until like 5 years ago, what was the state of the art for data quality? It was rule-based systems. You would define a bunch of rules, like, okay, here's foreign key relationships. Here's a rule that says, hey, if you see something like this, it has to be like this. Here's a dictionary of like acceptable date formats. And like, it was a nightmare. No one liked data cleaning, right? So, but the nice thing is that LLMs have reasoning capacity. So because of their reasoning power, they can actually go like 95%, 96% there with data quality checking and telling you things that don't make sense about the data if you actually have the right tooling built around these things, right? So the first thing where I feel like humans don't want to do it, they're not very good at doing it, AI doesn't mind doing it, AI is pretty good at doing it, will be data quality, right? I think the second one, which I think one of the other guests also talked about, is documentation. Documentation is, the textbook definition of what engineers hate to do, right? Well, AI is pretty good at doing this, and there's not much at stake, right? Like with data quality, you can do whatever rule system you have. This is an additional safety on top of it that like gives you better ROI. Same thing with documentation. Like, we have in our product team, they used like at Kibo, we used LLMs to create a bunch of base documentation, and then the product team went over them and improved them. So that's the second area, which is very easy to adopt. There's no lives at risk. You're just documenting an API, for God's sake, right? That's the second one. The third one is actually alerting. You can have your own alerts, but like figuring out, hey, based on this code, based on these common issues, based on the self-healing requirements that we need for our pipeline, like what are some additional alerts that we need to have? Yes, there's going to be a false positive, false negative, but alerting is another area where you can actually rely on the reasoning power of LLMs to sort of look at the code logic and figure out what are the conditions that it needs to alert you on, and you can actually provide feedback, and it will improve with the feedback. And finally, and this one is actually my own favorite, is resource management and cost optimization, right? The cost of like what data clouds have done in particular, like the likes of Snowflake and Databricks and others in this space, is that they've significantly lowered the adoption barrier, and they've really sped up like, what data engineering teams and data teams can achieve. But with that same token, they've significantly increased the cost of infra, because it's so much easier now to combine many different data sources. Everyone, even with less SQL skills, can tap into data pipelines. Modern data pipelines are way more complicated, and as a result, they're much harder to manually optimize. And the workloads are so dynamic in the cloud environment, you just can't do it, right? Like we've seen like massive success with with applying basically AI agents to cost optimization and automated real-time optimizations of, people's data clouds, Snowflake, Databricks. Like we have customers who've actually saved millions of dollars, literally, just by leveraging AI. And this is something that, you can't like page an engineer at 2 a.m. and say, hey, this container over there is underutilized. Your Snowflake warehouse over here could actually be downsized. This setting over here is suboptimal for the next 12 minutes. And then page them again 12 minutes later and say, now you can go back to sleep after the rep. AI can do it, doesn't mind doing it. And the reason why this one is my personal favorite is because the AI is really good at doing this. This is exactly what reinforcement learning is about. There is a reason why Kibo has been very successful automatically optimizing people's data infrastructure. Number one, it's doable. Number two, it's very expensive to operate these large data pipelines. Snowflake is a great tool, but it's not cheap. And the third one is that what's the thing that can go wrong? Instead of you saving, $13,000 last night, maybe you saved $12,500 and you still save money, right? So that's why I think this one is my personal favorite among those four things when I think data engineering can specifically leverage and benefit from AI agents.
Great. So thank you guys. Let's explore the reverse net. What are the things that just still have to stay, in the human domain? William, let's start with you. What do you really see as the kind of data engineering tasks that are best still done by humans?
So all these tasks I might mention here, I would still say that AI agents have a role, but not a dominant role. So they include high-level architecture design. I mean, AI agents can do some of that and offer suggestions, but I think it still requires a very smart data engineer to do that very well, because that makes a lot of difference in performance and efficacy of the uses of the data and so forth. So high-level architecture design, strategic decision-making, and guiding the agents with goals. We give agents the goals to execute on, and they do their goals very well, but we have to give them smart goals that are aligned with strategic decisions that need to be made for the company. I would also say complex problem solving and innovation, not straight up data analysis of alphanumeric data like we've been doing for a long time. That can be handled by agents, but when it gets more complicated, sometimes the agents will break down and not really be able to deal with all the nuances. I think that could change over time. And finally, I will add ethical reasoning and oversight. While we use agents to make sure we're in compliance, that is not ethics. The way that we use AI agents and AI in general, that has to do with ethics. So we have to give it the right data, give it representative data, and so on, and not give it data that is skewed in a way that could cause us some ethical issues. We have to ensure patient, if we're in a hospital, privacy and compliance, and the protection of all sensitive data. And that's not something that natively AI agents are going to do. So those are some things I think are still best handled by good data engineers.
What would so that's a great list, William. The architecture, the strategic guidance of the agents, what are the goals, complex problem solving that's still a little beyond the current state of the art. One's ethical reasoning, privacy checking, protections, making sure those things are built in, even if they're executed by agents. What would you guys add to that list? Arya, would you add something where you think to reinforce William's list or add to William's list of things still requiring humans? Oh, you're on mute.
Sorry about that. We're just moving, so I don't want to make too much noise. Yeah, so there's two aspects, right? There's one which is like actually like what is it that we're trying to hear? What is the task to execute it? And what are the requirements for this task, and what does the end state of the task actually look like? That's one aspect of it. Second aspect of it are basically the environment rules in which that we're working with, right? Every company has different rules on how data models are structured, how tests are structured, what our CI/CD pipeline looks like, and what are the rules that we should generally follow. If those rules don't exist, and that's not information that these language models actually have, they'll just kind of more or less follow the middle of the curve of what generally needs to be done and what's most common, which doesn't work for the majority of customers, right? So there's two aspects of it, which like we talked about, is just like what are the requirements, what does the end state of this task look like, so you actually have something that you can verify off of. Because if you don't have anything to verify off of, you will get a data model, you will get a test, but it very likely won't be actually what you're looking for at the end of the day, right? And the second aspect of it is just like environment rules of what should we follow, and can we actually verify whether or not these steps were followed or not.
Guy, would you add anything to those lists or reinforce that list?
Yeah, I think picking up on that point of governance and verification is really important. When I look at the customers we deal with, enterprise grade, like, we talked about the things that have to come together, the technology and the mindset, but, there's also, information security officers and, the standards themselves, whether you're SOC compliant or, 27001 compliant, there are a whole bunch of these things that were written assuming that people are going to be following books full of rules. So I think, when I look, if we take the examples of data pipeline, full of code and configuration and things like that, I see almost all of the use cases for designing and building that, great fit for AI. But I do not see a single enterprise customer today who's prepared to say, I'm gonna take a human readable description and I'm gonna get the AI to interpret that every hour and execute on every hour. What they want to do is use AI to build what is still a deterministic set of configuration and code. That's what gets human reviewed. That's what goes into the Git repository, and that's what gets executed every hour. We are not yet at a point where a data leader is going to say, you know what, I am so confident in the deterministic and repeatable performance of a model that I'm going to let it interpret and reinterpret every time it runs and bet my job on that. And so, there's an incredible amount, you can, optimize out thousands of hours of development, but at some point, some human being has said, you know what comes out of there is good. It's that human being that's certifying it. It's that human being who is putting their job on the line. I think the other area is, we talk about what, a lot of what AI is great at, but, it still fundamentally struggles at true novelty, So, the things that are brand new, that we're pushing out today, they're new today, and that really does need humans. Tomorrow it'll become commoditized and it'll become, well into the domain of the AI. I think the one other thing I just want to mention, though, having a lot of these, having these people actually work for me, like many others on the panel, we've got to bear in mind these are people as well. Just talking about what they can do, what they can't do. You've got to bear in mind things like people's preference. You say, well, I could end up with a company where the people are just doing this. But would I actually have any employees? Would they actually, could I recruit anybody for that? So we've got to balance what's possible with what people actually want to do, and and how to make a fulfilling job out of it. And when we first started working with the AI, I expected all of our engineers to jump on it wholeheartedly, and we had some people that were concerned that fear element. And it was interesting. You mentioned, Aria, the Industrial Revolution, and I think a lot of engineers think about it, software development or code development or data engineering like that. You say there's, when we invent a tractor, there's a lot less, farmers, a lot less people plowing the field. I actually think this is a different case. I treat AI as another layer of abstraction. We started out with binary coding, and then we got assembly language as an abstraction, and we got COBOL and Lisp as an abstraction, and then Pascal, and then C++. And every single time that we got a level of abstraction, people became 2 orders of magnitude more efficient. And the naysayers said, well, it'll be great for pet projects, but it'll never be good for mainstream, this, that, and the other. Yeah. When was the last time any of us ever wrote anything at lower level than C? It just doesn't happen. But what you would expect from that, you would extrapolate and say, well, if we get in 2 orders of magnitude more efficient every time there's a new abstraction layer, surely the number of practitioners is getting 2 orders of magnitude smaller. When you actually graph it out, you see the number of practitioners increases.
It only increases
with that. And I think the reason it's different from the Industrial Revolution is the Industrial Revolution is a constrained problem. There's only a certain number of fields, whereas we live, broadly speaking, in an unconstrained world where there are an almost infinite number of problems that we could look to solve. And it's back to the economics. I can't solve them today because the engineers are expensive. So if my engineering team became 10 times more effective, I'm not going to have 10 times less engineers. I'm going to have the same number of engineers solving 10 times more problems, or I'll say, well, economic, this is brilliant. I'm going to hire, another 20 engineers, and I'm going to solve 2,000 times more problems because, we're not constrained by the problem space as we are in the more traditional Industrial Revolution type, analogies. So I think it's a really, really exciting time for people to be getting on board with this. But there is, as Buzz said, there is an education process that we have to go through to bring people on that journey.
Yeah, I definitely agree with that point. In a lot of cases, demand ends up being elastic to the price, right? And I think another great example of this is a cloud, right? When you kind of look at what did it previously take to build a software company, right? Before the cloud is you would have to go buy your own servers, set them up on a rack somewhere, and continuously manage them, right? Now with the cloud, you don't have to do that. You no longer need a database administrator anymore, right? But that didn't necessarily mean that there's less database administrators. There's just now significantly more DevOps engineers that are now managing cloud infrastructure. So I think there's a really similar analogy here where, I mean, we're kind of seeing it now, right? People are just starting to roll out a lot more data infrastructure, a lot more data pipelines, gathering a lot more data, and at the end of the day, just delivering a lot more value to their end customers with the data that they're gathering. And that's really only increasing. And we kind of expect a very similar thing to happen here as it did with the cloud. Or really just the number of software applications getting rolled out has only exponentially increased ever since these cloud providers start popping up and offering cloud infrastructure at extremely low cost compared to what you previously have to manage.
Unlock better leads through Solutions Review events.
Welcome to Data Demo Day. Expert Roundtable, Solution Spotlight featuring Monte Carlo, Cohesity, Denodo, Cloudflare, High Gear, Broadcom, Next Thing.
Boost your brand with a webinar that shares comprehensive use cases, real-time product demos, and an interactive Q&A. All broadcast live to LinkedIn, YouTube, and Zoom from our Boston studio, or even on location. Fill your sales funnel with high-quality targeted leads. And contact us today by visiting solutionsreview.com/virtual events.
So in a sense, Guy and Arya are arguing that this is really creating new opportunity to do more, and there's business value to that. So William, where would you say the highest business value opportunities lie when you think about this whole domain and the data engineering? If data engineering was that much more productive, it was that much more insightful, it was that much more capable, where would that ROI show up?
Yeah, I mean, I can agree with Guy to a point on this in regards to efficiency and so on, but I don't think the problems or the challenges of a company are unbounded. I think they are bounded. And in the conferences I'm going to this season, just about in every talk, I hear talk of efficiency. I hear cycles being removed. I hear tasks being removed and given to the machine. It's happening at a very fast pace. And so I think that the best opportunity for companies to maintain or grow staffs is to grow the pot, is to grow the company with this AI. But other companies are doing the same thing. And so it's a really big competition right now to see who can use AI to grow their company and maintain what they've got and keep going. And I think it's going to create a whole new set of winners in the marketplace over the next few years. Those that can compete with AI are going to come out on top. Now, to answer your question, Bob, in terms of human AI agent collaboration, there are a tremendous amount of opportunities here short term. Automating those tedious and repetitive tasks that we've been talking about, taking that right off the table. I think about in domains, there's supply chain management is really ripe for the picking, and all those decisions that need to be made based upon data and need to be made quickly and smartly. I think the agents are ahead of the humans already in terms of that. And also, for better or for worse, customer service is another area that we are seeing agents kind of take over there. And like I say, for better or for worse, not sure it's better for the consumer, but it is definitely something that companies are finding good ROI in. And that was your question. So I'll put those two out there.
Great. Well, we've got about 10 minutes left. And so I'd like to shift gears for a moment because we've talked about opportunity, and all the things that could be done with these agents in collaboration with humans and how this might come together, whether it's a coaching model or a manager model, as the guy talked about, or putting together discrete workflows, et cetera, or as Farzan said, resource optimization, very focused on iterative capabilities. But let's talk about implementation. What are the critical considerations on, to make this successful. William, you're saying if you're not successful with this, you're going to go out of business in a sense, because your competitors are going to try to be successful. So what are those critical success factors? What are the key starting points? What are the few things you got to really be sure you do right? So why don't we start with you, Barzan? What do you think the most important considerations are as you start down that path and you want to achieve success?
Well, it's a great question. I think the answer is, like, let's think about what are the biggest obstacles that people have when they think about adopting AI, right? So one of the major ones is obviously security. And I'll give you like examples from the context of like our own company and how we sort of thought through these challenges, right? So one of the biggest challenges that people have, the second that the word AI comes out of your mouth, is like compliance, security, privacy. What about my data? Like, what, like, is my data gonna make your model smarter and somehow, creep into somewhat like my competitors' hands and whatnot, right? So the way we sort of thought about this was like, okay, how about we just shut that door from the get-go and just limit our agent to only learn from metadata. So we call it like no-brainer security model, meaning, and that's why we have a lot of like, public companies, Fortune 500 companies, Costco, many others who are using Kibo. And, we get into a room with their security team for a security review. 5 minutes later, like, get out of this room. You're wasting our time. Obviously, this is safe because you don't even see my data, right? So figure out, like, as a first step, like, as I said, like, if you want to walk before you run, figure out how you can get through the door by minimizing the type of data that you're training your agents on. So with Kibo, our goal was to auto-optimize customer Snowflake, save a ton of money. So we figured out a way to train our agents on telemetry data. So even the code is actually scrubbed, right? So that was the first thing. The other thing is the total cost of ownership, right? Like, data, like you don't want to have a solution that's very heavy-handed and requires a lot of maintenance, a lot of tuning from the client, right? Because people are constantly thinking about, okay, what? Let's say you came in and you did the POC, like, but what's the total cost of ownership? What's the maintenance cost of it, right? So figure out a situation where you can actually have self-healing models that self-learn, self-adapt, right? So like in our context with Kibo, like we used to joke with our customers that, like, hey, all we ask from you is 30 minutes of one engineer's time, and if we need more of that from your team, we'll give you an iPad for free. Obviously, we never had to give away any iPads, but the reason for that, because we created the models in a way where once we deployed them, there was zero maintenance afterwards, right? So the total cost of ownership, because customers might actually rightfully ask that, okay, this is AI, it's operating in my environment. Does that mean that I need to have 2 machine learning PhDs on standby to constantly, tune and oversee how this agent operates? And then the answer that we basically wanted to give to the customers, like, absolutely no, there shouldn't be any maintenance. And that basically makes you rethink about how you actually design your agent, how you use that agent. I think the third one that comes to mind is the ROI. And this is a purely marketing play out there, to be honest with you. A lot of the, not all of it, but a good portion of the hesitance that you see in the market against like adopting AI is because the marketing teams have really got overboard with it. They've overpromised and their teams have underdelivered. So a lot of CIOs that I talk to a lot of CIOs every week, like a lot of them have bruises from like teams and products and vendors who went there and promised them the world and didn't deliver anything, right? So then there's this degree of healthy skepticism that, okay, you're promising me the world and you want me to make an upfront investment. Am I ever going to see an ROI? So the way we thought about it was, okay, how about we actually make sure that you see the time to value? Like, we wanted to make that very short. We tell customers within 24 hours, you're going to see a drop in your Snowflake and Databricks saves, right? So you don't have to take my word for it. And then the pricing, the last point that was, we also want to make sure that the pricing is also a no-brainer. It's success-based pricing, that you don't have to pay us a penny if we don't save you money. If we save you $3, you give us $1, you take $2, right? So I think those are some steps that you can take to incentivize and de-risk that adoption from the customer's perspective.
So Barzan, that's obviously from a vendor's point of view, but I think some of those points still make sense from an internal point of view as well, because you constrained to internal known data, so you avoid the compliance and some of those issues. Minimizing the data that you're trying to optimize and learn on, so that you constrain the problem. Look for things with low total cost of ownership, because you spend a lot of time maintaining something. And then the inverse of that, make sure there's a hard ROI and you can prove it and not overpromise. Those are some of the factors that would go in. Arya, do you see some additional factors that critical considerations that need to go into place as companies and individuals and teams in data engineering implement these type of new capabilities?
Yeah, 100%. I mean, I think one of the mistakes that we often see from a lot of, especially enterprise customers, is they get a lot of heavy push from the C-suite team to adopt AI. We need to adopt AI to do something, right? But they don't actually know what are they trying to do with these language models and what is like the end value that they're trying to get out of it at the end of the day. And the perspective that we see through is just like any other piece of software that you're purchasing, which is, are you actually running into a problem today that needs to be solved? And how critical is that problem, right? So in our case, or like any other, like Kibo as an example, right? Let's say your Snowflake spend really is not high at all, and you probably have 2 Snowflake queries that are running, right? Maybe you don't actually need to spend a bunch of time there, or maybe on our end, you're not building that many data pipelines, and your whole product is managed by one, data pipeline in like a startup example, right? If you're not actually running into a problem, there's no particular reason why you should actually invest any meaningful amount of time exploring these tools, running POCs, and trying to just get something out of it when there's no actual problem that you're running into. So the perspective that we see this through is really no different than any other piece of infrastructure or software, right? At the end of the day, if you're not running into a problem that these models are solving, you probably shouldn't spend much time actually trying to find a use case for it, right? So really it's just find the problem first and figure out how you can solve it, rather than trying to find an AI solution to just like implement somewhere and then nothing comes out of it because you're not actually running into a problem, right? So I think that's one common mistake we see on the customer end rather than the vendor end. There's a lot on the vendor end as well that I can talk about, but from a customer perspective, it's just like build the solution around the problem.
It's a great one. This is such a classic too. Guy, what do you think? Equal considerations, best practice, success story, starting point. What do you advise?
Well, in terms of critical considerations, I think going back to what I said previously, I think thinking about people and being human, there is a big danger as we talk about machines, all the things machines are capable of. We forget that why we're here and the people we work with. So I think that human element is really important. I think another important one is knowledge management. One of the things I've seen happen very, very quickly, particularly in large products and code bases, is all of a sudden, like, we've very, very quickly delegated the knowledge management of our code base to the AI, because I don't need to know it. For most purposes, I don't need to know the file structure and the library structure, because when something needs to be implemented, the AI will find out the right place to implement it 99% of the time. But I think there is a danger in just completely delegating that to the AI. So I think knowledge management and the way we do knowledge management about our systems is important. But I think the final one, to pick up on what William said, if we talk about critical considerations at a business level, we've got to fundamentally think about what makes us different. What is our USP? It used to be you could go and hire 10 brilliant engineers and that would be enough USP to build a product. But today, a good chunk of my engineers are the same as Arya's engineers and William's engineers, because we're all using the same agents, or broadly speaking. So we've got to differentiate ourselves in different ways. We've got 10 companies trying to solve the same problem, and we're all using the same code generation models and things like that. We're going to have to do something different to differentiate ourselves. And so I think that's, to this, but there are going to be a lot of new winners coming up. And I think the hope of all of us on the panel is that, we're guiding our companies to be well placed to be those winners. But we've got to fundamentally work out what makes us different and how we're going to succeed when the 9 companies next to us are not going to.
So William, we'll give you the last word. You've seen a lot of implementations, mostly successful because of your involvement, but what would you say critical considerations are when it comes to this data engineering agent collaboration success?
So if organizations want to see success with their AI initiatives, they need to build trust. They need to build trust and culture that accepts AI into the right place in the organization. And in order to do this, they have to ensure that the AI they build has transparency, explainability, governance and oversight, appropriate human in the loop, and taking care of privacy and security. And in that way, the organization can come together around and know what they're trying to do with AI, and then go forward into ROI together with the agents.
Well, this is an awesome list. We've covered so much stuff. Usually at the end, I can summarize. I can't summarize today. You guys have thrown out so much great stuff. But, you know, we'll have another session next month. And it's entitled, it's Time to Get Smart About Data Intelligence. So we'll explore that subject in more detail. And the next jam session on June 6th will be hosted by Cher Fox, and it's entitled The Data Governance Wake Up Call. So be sure to set your alarms for that one. You won't miss it. And then I want to thank all our guests today. You did a great job covering this topic, this whole new domain of AI agents, this exploding change, and narrowing that into the data engineering domain and how to use that successfully. I think everyone got some great insights. I certainly did, and hope to see everyone back on the Insight Jam session next month. Bye-bye now.